Hello, I'm Jack. Welcome to my YouTube channel, Practical Programming with Dr. Su. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In the last few videos, we discussed how to map an image texture onto the 3D simple surfaces. In this video, I will explain how to use the texture framework created in the texture.ts file to create a 3D parametric surface with texture. Here, I will demonstrate how to create a Klein bottle, which is a typical example for 3D parametric surfaces. In order to create textures, I have added 9 images to the DRST assets folder, as we did in the last few videos. These images have the same size, 512 by 512 pixels, and the same PNG format. Here are 9 images we are going to use in these examples. Let's now consider the texture coordinates for 3D parametric surfaces. In parametric UV space, the value range in the UV plane is a rectangle. You can see here like this. Please don't confuse the variables U and V in the parametric equations with the UV used in the texture coordinates. In WebGL, we usually use S and T for the texture coordinates, while WebGPU uses UV as texture coordinates, which may cause confusions. So be careful when define texture coordinates on a 3D parametric surface. In parametric UV plane, the grades used to create a 3D parametric surface are divided with equal spacing along both U and V direction. You can see equal spacing here, is grades. And U can take a value, the range is from U minimum to U maximum. V can take a value from V minimum to V maximum. In this parametric space, we can easily map the texture coordinates to UV variable with this relation. You can see we can map texture coordinate to the UV variable. We define texture U component TU equal to U minus U minimum divided by U maximum minus U minimum. So in this relation, we can normalize the U in the range 0 and 1. When U change from U minimum to U maximum, TU will change from 0 to 1. Similarly, TV we define with V minus V minimum divided by V maximum minus V minimum. So when V change from V minimum to V maximum, the TV will change from 0 to 1. TU and TV are just the texture coordinates we want for our 3D parametric surface. Here we will use the Git tool to clone the source code used in the last video. Here is the download link. From this link, you can download the source code used in the last video. Now open a command prompt window and run the following command: git clone, paste this link. This will generate a WebGPU 38 folder on your local machine. This folder contains all the source code used in the last video. Now we want to change this folder's name to GPU 39. Rename Web 39 and cd into it. At this point, we are going to start Visual Studio Code with the command code period. This is Visual Studio Code interface. Okay, we can close this welcome page. Here contains the source code used in the last video. Now open a terminal window and run the command npm install to restore the npm packages used in this example. Okay, finished. Now all the installed packages are stored in the Node modules folder. First, we need to generate text coordinates for 3D parametric surface. From src folder, open the surface data.ts file. Now we need to add two new private functions to this file. One is Normalize Uv Parametric, and the other one is create core UV. With the new code, here we add these two functions here. Okay, here we need a vector 2. So because the text coordinate is two-dimensional, so we need to add vector 2 from geometrics package. So from here you can see the first we use Normalize UV Parametric to normalize the UV and UV value range. So we use the normalize formula we just discussed it. So we change the UV parameter range normalize to the 0 to 1 range. Here we introduce the UL and VL, so the range will be 0 to UL for U. V component is 0 to VL. So we convert the parameter UV into the text coordinates using this function. Create core UV methods accept 4 points in text coordinates as input. It returns text coordinates for a unit cell that consists of 2 triangles. This is one triangle, this is another triangle. With these 2 helper functions, we can now make changes to our parametric surface data method. Parametric surface data. Since this method involves changes in several places, here we will replace this method with new code. So we replace the code with a new code. First, as like the simple surface data, we introduce the 2 new input arguments, UL and VL. Inside this method, we define PUV array to store the UV coordinates for each vertex. You can see inside we call Normalize UV Parametric. So we convert the UV variable into the text coordinates. So we put this data into PUV1 array. So finally we put this array into PUV array. So we convert all the UV parameters for each vertex. Now we consider the unit cell. You can see here we define 4 points in the text coordinates for our unit cell. Then we call create a core UV function. This takes these 4 points as input. So we get the UV data for our unit cell. So we then put this result into the UV array. Finally, our parametric surface data function return UV data, as shown here. Now we finish the modification to this file. We can now save this file and close it. Next, we need to make changes to the index.html file. From a DRST folder, open this file. First, we need to change 38 to 39 because this is 39th video series. Next, we need to change the H1 title here from Peak Surface to Klein Bottom. The input parameter here we use in our current example will be the same as was used in the last video. So we don't need to make any further changes. Now we can save this file. Next, we need to make modifications to the main.ts file. From an src folder, open main.ts file. First, we need to change this simple surface data from surface data.ts file to parametric surface data. And also we need to change the peaks mass function from massfunc.ts file to Klein bottom. Of course, inside this create shape method, we need to replace the simple surface data to parametric surface data. And change this peaks function to Klein bottom. This U value range, but for our Klein bottom, U takes value from 0 to pi, and V take a value from 0 to 2 pi. And V division for our example we use 70, and V division we use 30. Next, we need to set the X and Z value range. We use -2 to 2, -2 to 2. Next, scale and scale Y. We still use 2 and 0. After that, the parameter is color map name. Here we use an empty string because we don't use it in our current example. Next is center location of our parametric surface. Here we use 0 and 0 and 0. And finally is UL and VL parameters. Okay, that's all. We don't need to make any more changes to this file. Now we finish the modification to the main.ts file, so we can save this file now. Up to now, we have finished all the programming. Now we can run the following command on the terminal window to bound our TypeScript code in production mode. npm run prod to bound our file. Okay, the bound file is created successfully. Now we can click Go Live link from the status bar area to open Chrome Canary to view our 3D parametric surface. So click this link. This is our textured Klein bottle with default lighting and texture displayed on this page. We can set different U length and V length, UL, VL. So for example, we change this to 4 and keep VL, V length 1, and address mode for U is mirror repeat. So we can redraw. So now we get a better looking Klein bottle. From this drop down menu, we can change the image. For example, here is earth, grass, Grand Canyon, Josego, marble, New York City, wood, Yellowstone. Let's go back the default break. Now we have completed this example. Most examples presented in this video series are based on my recently published book, Practical WebGPU Graphics. From this link, drsu.net.com, you can see the details about this book. I have created a GitHub repository to host the source code used in this video series. From this link, you can download the source code used in this video series. I also created a live demo at this link. This demo shows the live results by running the example projects. presented in this video series. I will end this video here. See you next time. Bye.